Hello everybody, Mike the Engineer. So you think you've heard all the silliest globe-denying claims. Couldn't possibly get any stranger, could it? Just when you think you've heard it all, you run into something even more outrageous. Today we're going to talk about a guy who claims that pi is wrong. Yes, we're talking about the circumference of a circle divided by its diameter. Yes, that pi. Not only does he say pi is wrong, but he says he knows what it really is. Big surprise. It's from a globe-denying flerf. Cue the intro. There's a member on the Flat Earth Society forum named Denier, and he claims that pi is incorrect. And at least they think it's Denier. It's spelled D-A-N-A-N-G, so that's how I'm pronouncing it anyway. I apologize to him if I've gotten it wrong. It's not my intent. However, not only does he claim it's wrong, but he's figured out what the real value is. Yes, he's figured out the real value that no one else has ever been able to figure out in the history of forever. And the value for him, and he calls it phew, yeah, P-H-E-W, I don't know why, it's 3.17157. That's right, exactly 3.17157. Denier claims it's not an irrational number. His reasoning seems to be that since the diameter is an exact number, circumference is an exact number, well then the ratio should be an exact number, right? I got nothing. Also, take note, 3.17157 is what he claims it to be now. Okay, we'll get back to that later. So here's what I'm going to do. I'm going to take a couple of discs. I got these 3 discs that I've cut out of half-inch foam board. I'm going to measure the circumference and I'm going to measure the diameter. And we're going to use those values to compare them to what we get for the ratio between the two. See what it comes out to. And then I'm going to take a couple of spheres and use a volume displacement in water technique to measure their volume. I had done this previously for Denier and posted my results on the Flat Earth Society forum, and he didn't like it. He said, "How do we know your instruments are right?" I had used a lab quality burette and a calibrated micrometer. Apparently that wasn't accurate enough for him. So I plan on doing this again, but this time I'm going to use a different technique. The one AB Science used in his experiment video, a much more efficient way to measure the volume of a sphere or of any object actually. So I'm going to use that. There'll be a link to that video in my description, as well as a link to AB Science's channel. I mean, if you're looking for a good channel, his is excellent. You should definitely sub to his channel. There's a reason for that, though. There's a reason I'm doing the spheres. Now, the spheres are small. One's an inch, one's somewhat smaller than an inch. And at those sizes, the amount of resolution you can get to be able to tell the difference between pi and his fake version of pi really isn't that good. We'd have to go out quite a few decimal places. But just when you thought it couldn't get any weirder, well, Denier's got his own equation for the volume of a sphere. Go figure. Can't tell you where it comes from. The reason I can't tell you is because he hasn't told anybody. And you'll get to see that later when I pop up a spreadsheet to compare all the numbers. Yeah, this is like getting kind of weird, isn't it? Well, let's go off and do some measurements. .5 cubic centimeters. Let's see, 8.6 milliliters, 8.6 cubic centimeters. Okay, this is a little simple spreadsheet that I created to compare Denier's version of the equation for a sphere to, well, the real equation for the volume of a sphere. His version equals 1/2 phi squared r cubed. So his value for the circumference over diameter he calls phi, and why it's squared I don't know, and where the 1/2 is I don't know comes from. He doesn't quantify that. He doesn't explain it very well. He did some hand waving as we previously seen, and the man is, I think, the king of word salad. So let me put in our measured diameter of the smaller sphere, which is 2.19 centimeters. Gives me an R of 1.095 centimeters. The measured volume of that sphere is 5.5. These are the values you get using this rearranged version of the equation, and anyone out there can check my math to make sure that I properly solved for R, and you can also check all these numbers on a calculator to make sure that I calculated it correctly. Lo and behold, if I use the correct equation for a sphere and I use pi, I get 2.19 centimeters. Isn't that interesting? No, not really, because it's just reality. And then let's try this larger of the two spheres. I had measured a diameter of 2.54 centimeters. It was exactly an inch. 2.54 centimeters. And what was the measured volume was 8.6 cubic centimeters. Well, would you look at that? Again, phi fails. His equation fails. Everything fails. I don't even know how any of that works. But lo and behold, if you use the correct equation and use the correct value for pi, you get 2.542. Okay, so the whole reason I did the volume of the sphere thing is because Denier has his own equations for the volume of a sphere. As you can see here, he starts out with an ampersand. I guess that's the character he wanted to use to represent a value of 3/4. Or as he describes it, gaining part of a square line is cut. Okay, I have no idea what that's supposed to mean. Okay, so then another member comes back and asks him, basically, what the fuck are you talking about? I'm going to read the first sentence of his post. All of this new formula is based on pi equals 3, or gaining proportion for the length of the dimension is 3/4, whose amount is 1.5 of total 2, the diameter, magnitude, or quarter of square line. 1.5 equals curve length, for quarter of a circle resulting from r equals velocity plus acceleration is greater than 1 plus a half applied for r1. Now, if anybody can tell me of any worse word salad than that, go ahead and post in the comments, because I really want to know. Okay, this is the basic integration of the volume of sphere. The reason I'm showing you this is because it illustrates clearly that C over D, which is pi, has absolutely no bearing whatsoever on how you come up with 4/3 r cubed. They're totally unrelated. Whatever the value of C over D is independent. Actually, the derivation of the volume of the sphere is independent of the value of C over D. You know, this is just a basic. You use the Pythagorean theorem to find out the size of the area of any disk sliced through this sphere, and then you just integrate that down till you get C over D times 4/3 r cubed. Denier, no matter what you do, you can't get anything other than 4/3 r cubed. And the nonsense that you've shown completely misses that point. You just made some shit up in order to try to make your phony value for pi to work. Denier also has what he calls a 6 radian experiment. As you can see here, he puts some paper tape on a glass mug and makes claims about how pi will get the wrong angle. And by that he means whatever angle 6 radians is in degrees short of 360 degrees, he calls that a gap. And for pi, it should be equal to 16.22 degrees, which I verified is correct. For phi, based on his stupid version of pi, it should come out to 19.47 degrees, 19.5. I also verified that if it were that value, that's what it would be. Of course, that really doesn't work when you think about it in the big scheme of things. He calls this the killer experiment, so that if you do this, you will not get 16.22 degrees. Now, so as you can see, this is the second disc, a radius of 12.5 centimeters. It's the 25 centimeter diameter disc. So 12.5 centimeters times 6 is 75 centimeters. So this is 75 centimeters around. 6 times. So that means that that line to the left is 75 centimeters in circumference. So the gap, as he puts it, is just over, as you can see on here, 16 degrees. Well, what's it supposed to be? Well, he says you calculate it out and it becomes 16.22 degrees would be the leftover amount, the gap he calls it, between the 6 radians and 2 pi radians. He says that that should be 19, and if you go ahead and measure it out, you should get 19.34, whatever he said it was. If it were that different too, you would see it. Obviously, we'd make that, move that line 3 degrees to the left. You would notice that. So there really isn't any way to say, I took your challenge, and guess what? You lost. But wait, there's more. I then took the 30 centimeter disc, the 15 centimeter radius. So let's see, 6 radians would be a circumference of 90 centimeters. And that's what that other line is. And look at it, it's also just over 16 degrees. Okay, got 3 discs that I'm going to use to measure circumference. And I'm going to use a fiberglass tape because it won't stretch. And full disclosure, the metal end was not straight couldn't get an accurate measurement, so I cut it off at just before the 2 centimeter mark. So now all my measurements will be very accurate as long as I remember to subtract that 2 centimeters. So the first disc is a 10 centimeter disc. So I'll wrap the tape around it. And I get 62.85. .20 centimeter disc. $78.55. 30 centimeter disc. $94.25. So now we're going to figure out, we measured the circumference of these 3 discs, the 20, 25, and 30. Now we're going to figure out the ratio of that circumference divided by the diameter is. So for the 20 centimeter disc, I got, let me go to my note, 62.85. Well, that works out to be 3.1425. Pretty close. Now you see, these are going to, let me do this one first. 78.55 and 94.25. So as you can see, all of these come out to close to the current value of pi. Well, let's see what happens if I calculate what that circumference should be based on the radius times pi 62.83 versus 62.85. Pretty damn close, don't you think? What would it have been if I had done using the fake value of pi? So this equals 20. 63.43. That's actually a pretty big gap. Let's see what happens here if I go for the 25 and 30 centimeter discs. This one is approaching a full centimeter difference. The calculated values are very, oh, this one's like almost exact, is very close. What is this really? Okay. So the calculated values are very close to the measured values. Very, very close. Well within accuracy of any measurement. So as you can see, circles, measured circles, kill the fake pi number. The thing to remember is that pi is simply the circumference of a circle divided by its diameter. It's nothing more than that. There's nothing very complicated about it. And today, it's actually fairly simple, with simple measurement tools to accurately determine the value of pi. And in my case, I used a fiberglass measuring tape from a fabric store. I cut cut the end off to make sure that it was really accurate, just before the 2 centimeter mark. And as long as I take into account the 2 centimeter offset, I get very accurate measurements. And as long as that's the thing I'm using to measure the diameter and to measure the circumference, the ratio of the two is what it is. There's no magic to that. And it shouldn't be that hard to get an accurate value. Hell, we give school kids a disc and a piece of string, and their unit of measurement is 1 string, literally, and that's all you need to know. As long as it's the same string that measures the diameter and the same string you use to measure the circumference, guess what? You're going to get an accurate measurement. And they usually get around, 3.15. That much more accurate than anything Denier has ever done. And previously, I had tried other analytical techniques to show him. You know what? Let's take a look at a couple of those. Okay, so I have in the past attempted to provide some calculations to Denier to show what the bounds of pi would be. So I tried the typical polygons. One external to the circle that is tangent to the circle, and then one internal to the circle where the vertices of the polygon, and as you can see in the upper left hand corner, the square in this case, the vertices of the corners are against the sphere. Also, if you look at the right hand page, the external circle, the external polygon, I presented to him that, if you have this external polygon, whatever value that is the upper bound for pi. So if you take this r over the perimeter of this r times 2, so the perimeter of this external polygon divide over twice the radius, this little r, whatever that value is larger than the actual value of circumference over the diameter of the inscribed circle in here. So he's trying to say now that we get to a point where you increase the number of sides, and for some reason the perimeter of the circle, the circumference, starts to exceed that of the polygon. You heard that right. It makes no sense. Completely illogical. You know what? We'll come back to that. Now, his latest thing about this polygon, I recently posted in one of his threads on the Flat Earth Society forum that based on a polygon tangent to the circumference of a circle, that it is physically impossible for the ratio of C over D of that circle to be larger than that of the polygon. And when you get to like 96 sides, you're down to a polygon C over D, a polygon perimeter, actually with P over D in this case. So the polygon perimeter over the diameter across the flats of the polygon gets to be like, I think it was 3.15 something. So from that standpoint, I made the assumption if we stop there, then it is impossible for C over D of the circle for which this polygon is tangent to be larger than that value. So it would be physically impossible for it to be 3.17. Of course, he dismissed this, and he actually claims that if you add enough sides, then the circle becomes larger than the polygon. You heard that right. The fact that this area here will always exist, no matter how small, for a polygon. He says at some point, C over D of the circle becomes larger than P over D of the polygon. Well, there you have it. Denier, we did direct measurements of both the circumference of circles and your 6 radian experiment, and direct measurement of the volume of spheres and the diameter of spheres. And in all cases, we've even shown that it comes out to pi. And we've shown that your fake value of pi is wrong in so many different ways. I've shown with the polygon example, the bounding polygon examples, that it is physically impossible for your circle to be bigger than the polygon that's tangent to that circle. And to say anything other than that is just disingenuous on your part. I mean, you've made the claim. You're one of those globe-denying flerfs who thinks that a claim is evidence of itself, but you've provided no evidence to support any of your claims. Just a lot of hand-waving, some stuff you've said, some numbers you've made up, but you don't tell anybody where those numbers came from, or how you derived them, or how you calculated them, or how you measured them. So, claims made without evidence can be dismissed without evidence. In other words, you're out of gas. Denying your so-called few is thoroughly destroyed. I'm Mike the Engineer, and I'll see you guys in my next video about some more globe-denying stupidity. Good night.